Hello, hello everyone. Thanks for being patient there. We just had a little technical issue, but we're ready to get started. So, hi, I'm Misha from IDERA, and welcome to the webinar, Architecting for Performance in the Cloud Environment. Also, I'm joined from IDERA by Mark Slavin. He'll be sharing some information about SQL Diagnostic Manager later in the presentation. Just to let you know, this webcast will be recorded, so you'll be able to view it again after, and you'll be receiving an email with a link. So at this time, I'd like to turn things over to our presenter, John Morehouse from Denny Cherry and Associates, and he will start our presentation. So over to you, John.
Cool, thank you very much. I hope everybody can hear me. As mentioned, I apologize. We had some network issues on my end. Of course, I got a new laptop for work, and it's been working fine for a week or so, and then 30 minutes ago, it decided not to work. So apologize for the delay. And today we're going to talk about architecting for performance in a cloud environment. This presentation is kind of a higher level of what things to think about from a performance aspect when you're looking to either move into the cloud, or maybe you're already in the cloud environment and you're seeing performance issues and whatnot. And I think subsequently later we'll have another deeper dive into some performance issues related to SQL Server, and more specifically in the cloud. As mentioned, my name is John Morehouse, and my clicker doesn't want to work, of course. That's been a day. I'm a principal consultant with Denny Cherry and Associates. My contact information is on the slide before you. You can contact me at john@dcac.com. You're welcome to email me about questions about the presentation or comments. I always appreciate feedback, or even if you've got SQL Server problems going on and you don't know where to go, or you just need someone to point you in the right direction, I'm happy to help. I'm very much involved in the SQL Server community as a whole. My LinkedIn information is there. I'm on Twitter. It's about the only social media outlet that I'm on. I do blog. I live in Kentucky. I'm honored to be a data platform MVP with Microsoft. I do have to give a shout out to IDERA. IDERA had a program called IDERA ACE, and it was a stepping stone in my progression in my career and helping me to get to that MVP platform as well. I do a lot of stuff in the community. I like to talk, I like to blog if I can. Something I need to get back into. But quick blurb about DCAC. We're a small boutique of IT professionals who like to solve business needs usually with SQL Server. If you need database help, we're happy to talk to you. That's a quick blurb about us. Here's a quick agenda that we're going to go over. We're going to talk about location, why that's important. We'll talk about different service offerings from a cloud provider, different service tiers, caching, and as the abstract mentioned, I actually am going to throw in some cost savings, much to the chagrin of most cloud providers, because they really pretty much want your money. So I'll point out some cost savings that you can do when you're in the cloud to help save on those green dollar bills. And then maybe Q&A that we have left, and at the end of the presentation, somebody from IDERA is going to demonstrate a diagnostic. So up front, we still have to have this conversation in the year of our Lord 2022 or 2023. Actually, I'm sorry. There is no cloud, it's just somebody else's computer. So when we go to the cloud provider, and I'm going to be pretty much cloud agnostic, I'm going to try to be. I play my day-to-day operations. I spend almost all my time in the Microsoft Azure space. I do have some clients that run in Amazon AWS, but this presentation, I'm going to try to be mostly agnostic about things. But when we think about performance, we still have engagements where clients move to the cloud and they think that everything is going to be magically delicious and significantly better from a performance standpoint. And depending on how that migration was implemented, that may or may not be the case. If you have an on-premise implementation, which if you're older like I am, you definitely probably remember those older implementations where you had more granular control over things. When we go to the cloud, we still have some control depending on what service offering, what service tier you go to, but it really is just somebody else's computer. You're renting that hardware from that provider, whether it's Google Public Cloud or Amazon or AWS, you're just renting that hardware. The other thing that I'm going to throw out there up front And while I love SQL Server, and I'd be happy to sell you SQL Server licensing and do SQL Server services for you or with you. I'm a huge proponent of trying to find the right solution. And we've run into organizations where they've implemented SQL Server in the cloud. And from a performance standpoint, SQL Server actually wasn't probably the best option for their particular application and their data stores behind the scenes. If you're not in the cloud already and you're thinking about moving, and you might want to think about whether or not SQL Server is a good fit for you in the cloud, there are other options out there. You can go to MySQL or Mongo or what have you for a different option of the data store to get better performance. Again, I would love to sell you SQL Server. I would love to work with SQL Server. I will almost always recommend SQL Server, but there are times where SQL Server is not the best option for you in the cloud from a performance standpoint. This one, location, location, location. So we're going to talk about location. In the cloud, location really does matter. We still have organizations, I see it on on Twitter and forum posts and whatnot. An organization would go to a specific region. Cloud providers offer different regions around the world where you can put resources, whether that's web servers, database servers, whatever. Where you put those resources makes a big difference. In the consulting world, at least from Denny Chair and Associates, we always joke that you can't beat the laws of nature. Physics always will win, and you can't beat the speed of light. There's no amount of money can we beat the speed of light. The bigger your checkbook is, that we can make things better, but you'll never be able to beat the speed of light. So we've seen organizations where they put resources in one region of the world when reality is that their consumers are located somewhere else. A good example is they might put resources in the East US, so think Virginia of the United States, but in reality, 80 to 90% of their downstream consumers are located in West US, which is entirely across the United States. That data might have to transverse the entire continental United States in order to get to those downstream consumers. And that's a horrible performance impact, and probably not a good, fun user experience for your customers. So where we put things does matter. All of the major cloud providers, this is an old map of Microsoft Azure. It's one that I've used in previous presentations before. Really, it's just used to highlight that in AWS, Google Cloud, all the major cloud providers have the same similar concepts of whether you're going, doesn't matter which cloud provider you're going to, have these concepts of regions where you can put resources around the world to make things better. A good example that I always use is the company I work for, Denny Chair and Associates. We do have a web presence, and a couple of years ago, Denny, the founder and co-owner and the owner of the company and my boss, discovered that we were getting significant web traffic from outside of the United States, and I think it was near Australia, in that part of the world. And unfortunately, at that time, all the web traffic was traveling all the way back to West US in the United States to get the website and to render that web page. And so we were actually able to use the power of the cloud by replicating the website closer to the Australian individuals who were searching for us to look for information or to find resources. And we were able to stand up copies of the website in a different region around the world, which made their end user experience significantly better. So when you start to think about where you are in the cloud, and I've seen organizations, they go to one region, their CEO lives on the east side of the United States, and that's what they just chose. They pick random reasons as to go into certain regions. If you're not in the cloud, or even if you're in the cloud already, you can think about moving to different regions that are closer to your downstream consumers. At least in Azure, you do have an ability to move resources. There are tools available that you can do that. That might be a planned migration to make that move, but something to think about and something to look at. Service offerings. So location is important. The other thing that I've seen quite often in the cloud when dealing with individuals or organizations who want to move to the cloud or they're already there, they don't choose the right service offering for their given workloads from a database perspective. So when we talk about service offerings, what I'm talking about is your differences between traditional on-premises, infrastructure as a service, and platform as a service. So your traditional on-premises, of course, if you've seen any cloud-oriented talk in the last several years, you've probably seen this multiple times. Traditional on-premises, you get to control the entire stack from the networking all the way up to the application. You've got very granular control in terms of how your application might behave from a performance standpoint. You can tweak those network switches, you can tweak the storage arrays, you can tweak the servers and the virtualization settings. As we move into the cloud, we have less control over that. So like infrastructure as a service, that's essentially a virtual machine that is hosted by a cloud provider. The cloud provider will manage and control the virtualization layer and everything underneath. So we still have some access to the operating system, the middleware, the runtimes. We can, at least in Azure and AWS, I have a ton of experience with Google Cloud, but the concept is the same. We can do certain things with like disk pooling and storage spaces to help maximize performance from a disk perspective. We can still do that from an infrastructure as a service. However, we don't have access to the physical hardware. We can't walk into the data center and swap drives or tweak that underlying hypervisor per se for a performance perspective. Platform as a service, we go further up the stack where we have less granular control to tweak things from a performance perspective. We've got access to applications and data, and platform as a service is going to be like an Azure SQL database. AWS doesn't really have a comparable equivalent. Their comparable equivalent is RDS, and that's more like a managed instance, I guess. I guess it is platform as a service. But the point is that if we go into a platform as a service offering, our options to tweak things for performance can be less than what we had on traditional on-premises. And of course, software as a service is the last one. In this case, software as a service, we don't have access to pretty much anything. I'm just pointing that out just from a completion standpoint. And really what we're going to talk about today is the infrastructure as a service and platform as a service from a cloud offering in terms of how we look at things from a performance issue. The point being is that if you go to a cloud implementation, do the due diligence and look to make sure that the platform can support what your performance needs are. We've seen organizations that have moved to certain offerings, whether it's infrastructure as a service or platform as a service, and they think that the performance is going to be equivalent to what it is on premises, and that doesn't necessarily happen just because of the nature of the beast and how we have to handle those two offerings from a cloud provider. It's not necessarily a one-to-one correlation to your traditional on-premises implementation. So there are things to evaluate before you go to the cloud. As much as I love Azure and I love Azure SQL Database and Azure SQL Managed Instance, I've seen organizations where managed instance wasn't the best solution for them, or the Azure SQL Database wasn't the best solution for them, and they may or may not have had issues with either one of those two platforms. Same thing with AWS. I've seen organizations that have moved to RDS and their performance tanks because of the way the nature of their workload is. And so my recommendation is to make sure that you evaluate each offering respectively to ensure that it can meet your performance requirements. Service tiers, and this is where we're going to get kind of more into the nuts and bolts of things. With service tiers, and really what I'm talking about is how we understand what the service tiers are for those service offerings. So of course, with your traditional on-premises implementation, you've got full access to everything, as I mentioned. you can walk into that data closet and start pulling drives, tweaking those network switches. You can do things hands-on, whereas when we're in the cloud, we have less granular control of that. So when we talk about infrastructure as a service, and this is about the VM or the virtual machine sizing, and infrastructure as a service is going to be closer aligned to your on-premises implementation. Remember, with infrastructure as a service, we have access to the operating system of things, and so we can tweak certain operating system level settings to make sure that it's closer aligned to what you might see on premises. So if your application or your workloads require certain configurations, virtual machines in the cloud might be able to manage and satisfy those requirements, and so that's something to think about. Hardware selection. When we talk about VM sizes, and I've got some graphics here coming up to help highlight this. If you look at the virtual machine sizing for any viable cloud provider, so whether it's AWS, Azure, Google Cloud, you can select hardware based off your number of CPU cores that you want, the amount of memory you want, and or how much throughput you want from that virtual machine. Now, with those, in all of the providers have various categories for that hardware selection. So, and one of the really cool things about infrastructure as a service, especially in the cloud, is that you can actually resize the virtual machine with a simple restart. So one of the things to keep in mind is if you implement a workload into a cloud provider, and again, I'm going to use Azure as an example. If I have a given hardware size, 4 cores, 16 gigs of memory, I put a workload against that virtual machine, and it turns out that that virtual machine doesn't have enough horsepower to handle that workload. As long as I can withstand a minor outage, I can restart. I can upsize that virtual machine with a simple restart. And upon that restart, I actually will get more cores, more memory, more throughput. So that's one of the things I love about the cloud is I can easily scale things up as long as I can withstand that minor outage. So if you're looking at infrastructure as a service, make sure that you evaluate your CPU cores, your memory, your throughput needs to ensure that you pick the right VM. Now, again, you can easily scale that up. And each cloud provider does have different categories, as I mentioned. And those categories usually are dependent on what you are looking for in terms of, for a database server, you may want a higher ratio of cores to memory, meaning the amount of memory you get is based off the number of cores. So with a memory optimized virtual machine, I get a higher ratio of memory. With SQL Server, I want as much memory as possible because SQL Server loves to have memory. And the more memory I have, odds are the better that it will perform. So all 3 cloud providers have a memory optimized virtual machine size that you can pick to get that higher ratio. Most organizations have a development world, so they want a lower size virtual machine because they don't need that heavy duty horsepower for a non-production environment. So you can select, excuse me, you can select which appropriate VM size that you want for your needs. The other thing I will throw out here from a performance perspective is disk quantity limitations. So if we look at, and I mentioned I've got screenshots for both AWS and Azure here coming up. And I've run into this before. Some of the virtual machine sizes actually limit you as to how many disks you can attach to your virtual machine. And so what happens is that you actually run out of room to attach additional disks and you have to upsize. Again, you can upsize that with a simple restart, so it's not that big of an issue. But if you know that you're going to have multiple disks and you're going to use storage spaces and pull your disks together to optimize throughput, you need to make sure that you look at what's the disk quantity for a given VM size so you don't have to incur that amount of restarts. While that restart might be 30 seconds, 60 seconds, it's still an irritant to actually do that restart. Simple as it is, but it's still a pain in the butt sometimes. Disk performance options. I don't have a slide deck, or I don't have a screenshot of this specifically, but in correlation to the disk quantity, we need to look at the disk performance options for the given virtual machine and the disk that we're attaching to it. If you look at both AWS and Azure, you can attach various kinds of disks to virtual machines. So in Azure, the highest performing disk is an Ultra SSD. You get super duper fast performance at a cost. Of course, everything in the cloud costs money because the cloud providers need to make money as well. So if your workloads absolutely need that higher end performance, and Ultra SSDs attached to your virtual machines might satisfy that. And so there are options to pick which hard drive type that you want to attach to that virtual machine. You can go down to a lower standard hard drive. When I say a standard hard drive, I mean, think about in the old school days where you had a spinning disk. We call that a slow spinning disk SSD, but actually had hard drive platters within the enclosure. You can attach that type of disk to say non-production environment to save on money. If you don't need that super fast performance, you can go all the way back the other direction and install that lower tiered performing disk for that virtual machine. In addition to that, the virtual machine will also potentially limit what your throughput is to your underlying disks that are attached. The virtual machines, if you go out to like AWS or Azure and start looking at the various sizes, they will tell you what those throughput limitations are. So if you have a workload, let's take SQL Server for example, that has a ton of writes and you need the highest amount of throughput for a given virtual machine or throughput for the disks, you may have to go up a size depending on what your needs are. What we've seen before is people will implement various virtual machine sizes, core counts, memory, all that. It's all hunky-dory. However, they're being throttled on the back end because there is a throughput limitation that's being imposed by that cloud provider. And so oftentimes when we get involved, one of the things that we will check is to see, one, what that throughput is. Are we hitting that limitation? And what can we do to fix it? We can size up, we can change various things behind the scenes. So looking at the overall disk performance and the throughput is pretty critical. One of the other things that we see, and I've seen this recently, is not using locally attached ephemeral disks when needed. Oftentimes, and when you look at Azure sizing, you will see that the virtual machine may or may not come with a locally attached temporary disk. Now, when I say temporary, I'm not referring necessarily to TempDB, although we recommend that we use that disk for TempDB because it's one, locally attached, and two, it's really fast. The downside is that it's ephemeral. That means that it's temporary. So if we reboot that virtual machine, that disk is actually going to go away. Given the nature of TempDB being rebuilt upon a restart, we tend to like using that ephemeral disk because we want the best performance for TempDB, and we don't care if SQL Server has to rebuild TempDB every time it restarts. Those are great examples as to why we want to use those ephemeral disks. Don't use ephemeral disks for data that you want to keep, obviously, because if you restart the virtual machine, and AWS has the same concept, you get great performance, but it's a temporary drive. If you restart that virtual machine, that drive is going to go away, and everything that's on that drive is going to go away from your virtual machine. So they're low latency, but high performing. If you need that type of workloads, you can use those disks. Just keep in mind that they are temporary. Database-oriented VM size, I kind of already mentioned that. There is memory optimized virtual machine sizes for AWS, Google Cloud, all that are best suited for platforms like SQL Server. So go look at, and between the three cloud providers, they basically all have some common similarities in terms of categories for virtual machine sizes. AWS seems to have a little bit more than Azure. Google Cloud is not as robust as the others, but it's slowly catching up. We can start to see new categories come out from Google Cloud. But this is an example for Azure. You can see that these sizes there on the left, these are the standard E2 BDS V5s. These are relatively new to Azure. What you can notice is a couple things out of this category is that they have a pretty good high ratio from vCore to memory. For example, if we look at that bottom one, that 64 core machine's got 0.5 terabyte of memory on it. That's a pretty good ratio for, and this is a database, memory optimized, high performing database platform. There's a woman in Microsoft, her name's Pamela, who she's in charge of the virtual machines in Azure or SQL. And she calls these double sprinkles because these are great performing virtual machines for running SQL Server specifically. The other thing that I want to point out though is that you can see here the number of disks I can attach to that 64 core machine is 32. So if I have to attach a lot of disks or I need high amount of disk volume, then I need to be paying attention to that. The other thing I wanted to point out was looking at those throughputs for those IOPS is important. So we can see that the 2-core virtual machine has significantly less throughput for IOPS than that 64 core. It kind of makes sense. We get more cores, we need more throughput, and so we get that higher throughput with that higher core VM. Now, of course, AWS does the exact same thing. And you can see the categories on the left. If you need accelerated computing, you need storage optimized, whatever your workloads needs, all three providers probably have a category that would fit your needs. But same kind of concept here, based off the number of cores will dictate what your bandwidth is for your EBS volume. Your EBS volume is synonymous to an Azure disk behind the scenes. That's the disk that we would attach to that virtual machine. But looking at that bandwidth and that throughput makes a difference and needs to be identified and recognized as to when we move to the cloud to ensure that we get optimal performance. So I'm going to move into platform as a service. Here I'm going to talk specifically about Azure because that's where I play most of the world or most of the time. AWS has a similar concept. I don't have any experience with Google Cloud specifically. I wasn't able to find an actual platform as a service offering. They do have a virtual machine infrastructure as a service offering, but I haven't been able to find any documentation on platform as a service. If I'm wrong, feel free to correct me, send me a note. I'm always happy to learn, and I want to learn about other platforms as well. So in the Azure world for platform as a service, we've got and remember that platform as a service, we've gone further up the stack, the technology stack. So we virtualized or obfuscated away the operating system. The only thing we have access to is basically SQL in the database. We don't have access to Windows or Linux or the underlying hardware for platform as a service. And they offer pretty much 3 different tiers. The first 2 tiers, the general purpose and the business critical, are only for managed instance, but all 3 here are for Azure SQL Database. So general purpose, if you are going to the cloud, and one thing I didn't mention, I don't have a slide on, is that Azure SQL Database specifically, not managed instance, but the database side of things, you can get what's called a DTU, which is a database transmission unit size service tier, where it is a smaller performing or less performing potentially service tier than using like general purpose or business critical or hyperscale. You don't get dedicated cores in that service tier. Whereas if we do a general purpose, we can see here in front of us, the general purpose will cover probably the majority of workloads. None of my customers that I deal with today are out of general purpose, meaning that their workloads work just fine in the general purpose service tier, and it's a good combination of easeability of configuration, but also it helps minimize costs. Because of course, if you go into the higher tiers, if you go into that business critical, just the term business critical screams pay me more money. So if you go into those higher tiers, you're going to get a higher monthly cost potentially for those tiers. That might be entirely worth it for your organization, but that's something to keep in mind. So the one thing I want to point out about the general purpose is the remote storage. So when we talk about performance, when we go to the cloud, even in a platform as a service, we want to understand how performance is affected by the way that the architecture works. With general purpose, we are actually behind the scenes, and we can't see it per se, like we can't configure it, but the disks that are holding and supporting your databases are actually remote storage. And so they're network attached. And so those IOPS, all that throughput has to travel through that network to that remote storage. Can that affect your workloads? Potentially, absolutely. Without seeing your workloads and running some tests and doing some diagnostics, I can't tell you 100%. But if you have a workload that is highly sensitive to latency, throughput, what have you, the general purpose service tier may or may not be sufficient for what your needs are. Obviously, we can scale up to a very high number of cores, 128 cores, but really from a performance perspective, I want to point out that the remote storage could be an issue. If we go into the business critical, you'll notice that there's actually a locally attached SSD as your storage. So our latency is less than the network attached storage. And so we get better throughput, better latency, but it comes at a increased cost because again, if we go into the business critical, that screams money and Microsoft loves to get paid. And so just know that if we go into the platforms of service tier, business critical will get you the best performance potentially for your workloads, but it comes at a higher cost. And that's at an increased cost and partly because we have a locally attached storage. And so we get better performance. Hyperscale. So hyperscale only applies to Azure SQL database. It has a completely different underlying architecture. They actually split out the compute nodes and they've introduced a log service and what are called page servers to increase the throughput and the performance of your database. There's SSD-based caches on the compute nodes, which equals to faster performance, and it kind of looks like this. I borrowed this from Microsoft.com. We can see here that this is not your traditional implementation of what most people probably think of from a SQL Server implementation. We can see like on the left where we have region 1, we've got an SSD cache with a database. There's a log service that sits between the page servers. The page servers actually is what holds your data files. And so your performance can be pretty significantly improved by going to hyperscale. I don't have any clients that are actually using it because there is a cost, just like with business critical. If you go to hyperscale, your costs may or may not increase. So you need to evaluate that when we start looking at whether or not your workload will function well within the hyperscale. Another thing I want to point out, elastic pools. So I looked around AWS and Google Cloud. I don't think have anything comparable in terms of the concept. And really with elastic pools with Azure SQL Database, it only applies to Azure SQL Database. You can't do elastic pools with managed instances. We can actually group databases together. I always think about this as an actual pool where you go swimming in the pool. Just like the image on the slide shows, we've got individuals that are obviously swimming a race, and each lane can represent an individual CPU core. So one of the beauties about elastic pools is that we can group all the pools together at a fixed cost. So we kind of help manage and control costs from a cloud perspective, at least from Azure. And we can offset CPU patterns. So if we have a bunch of databases that have not similar CPU patterns, a good example would be Maybe I have an online transactional data store that services my application during the day, but then I've got a data warehouse that does loads at night where, I'm maybe in a bank and I work 9 to 5. That ETL load would run outside the confines of the day-to-day operations. I can group those two databases together to share CPU resources. Those CPU resources I can set limits on, and so that pool could be set to say 16 cores. Those 16 cores can be used across all the databases, but I can specify a limit from a per database setting. So out of those 16, I can say any one database can use 12 cores, as you can see in the example. It's just a slider option in the Azure portal. You can slide that up and down, so that one database can't throttle the others. The beauty is that each database within the pool can then automatically scale to what it needs. So if most day-to-day, the database only needs 4 cores, it'll get 4 cores. But you do Black Friday sale and your sales are going to go through the roof, that database could potentially scale all the way up to 12, consume all 12 to do its workload, and then release, and then the other databases can use those cores. I love elastic pools. I think it's a great way to do Azure SQL database. So if you're not using elastic pools, might think about doing that. AWS, I wanted to touch on the other cloud providers. I know that I talked about a lot about Azure. The RDS, platform as a service, it's more aligned to what you can think about like an Azure managed instance, where it's not a single database on a logical server. You actually get a full-blown SQL Server instance. There are 2 categories for their platform as a service offering: is general purpose and memory optimized. But the disks behind it are very much like EBS volumes. So you get a wide range of performance options that you can configure with your potentially with your RDS instance. So it's not quite like Azure SQL Database. It's more aligned like an Azure managed instance. Google Cloud, as I said before, I could not find a true platform as a service offering. But you can see here that they do have very similar categories for their virtual machines. We can see that they have general purpose, they have got cost optimized, they compute. One thing I did notice, and I didn't highlight it in the slide, if you look at that CPU definition, I think it's interesting that some of their virtual machine sizes, they define a virtual CPU core as a thread versus a core. I have not noticed that in AWS or Azure, but that did catch my attention. So this might be a time where you start to, if you are thinking about going to Google Cloud, looking at how they define that, so you have a better understanding of whether or not that's going to be applicable to your given workload. Again, I don't have any customers running in GCP yet. I expect that Google Cloud is going to catch up to Azure and AWS, and we're going to start to get customers running in that cloud provider. Caching, and I don't think we have any questions. Oh, somebody did. I don't know. I'll have to look at that. Thanks, Brian. Caching. This is one thing that I wished more organizations took advantage of. I still have organizations that don't take advantage of this, and I don't know who said this quote. The fastest query is when you don't have to execute. This is a quote that I've been using more frequently lately in terms of trying to get my clients to utilize appropriate caching in their applications when necessary. A good example that I have is I have a client, and like I noticed that they had a query that was executing several, like tens of thousands of times a second. Now, thankfully, those queries were very fast performing. They performed very, very well. However, it's death by 1,000 cuts. And so we are actually seeing some elevation in CPU time and some other things to help identify, hey, this might be a good candidate from a caching perspective. Because like one of the things that they would do is they would call about information from the database about their customers every time the page on the website would refresh. So every time they did something on the web page, they'd make another call to data that is static and would not change. So one of the things is that I think application caching from a standpoint has been around for a long time, but now it's not just for applications. We should actually be caching specific database calls. If we don't need to refresh that data that often, please, please, please think about implementing a caching layer like Redis cache or some other mechanism to help cache some of that data from your databases. My favorite is the customer information. If the customer information isn't changing that frequently, or the states of the United States, the individual states, that information is probably not going to change anytime soon. So let's not call that with every single refresh of the page, because if I don't have to execute that query, then I don't want to execute that query because I'm going to get better performance and I'm going to save money probably somewhere. So if you look in your workloads and you're doing millions of calls per minute, that might be an indication. And the millions of calls per minute doesn't correlate to a higher consumer downstream, meaning the number of connections, the number of users hasn't increased. That might be an indication of I can maybe cache some of this information for better performance. Because if I don't have to do the database call, then the application can run faster. That's just, if I don't have to do the query, that's the fastest query I can execute is one that I don't have to. So I'm a huge proponent of caching, and I wish more organizations would look at their database layer specifically to see where we could implement caching to make things better. Okay, so that was really quick. I'm at 15 minutes. I know I got to give time for the diagnostic manager demonstration and Q&A, but I mentioned cost savings. So I'm a huge proponent of saving money in the cloud. I know all the cloud providers want their money, but here are some ways that we can help save money in the cloud. Proper indexing and maintenance, and this is specifically geared towards SQL Server. We often will see organizations who move to the cloud, and while their performance on premises might be fine, it may or may not be fine in the cloud, and they don't do proper indexing and maintenance. If you have a steady SQL Server DBA, they probably have been working on this for quite some time, but I will attest that proper indexing and maintenance, even in the cloud, can significantly help you save money. My colleague, Monica Rathbun, we had a client and she was implementing proper indexing and maintenance and code tuning in the cloud for a client, and she was able to save them significant amounts of money because they were able to scale resources down just simply by doing proper indexing and maintenance and code tuning. Reduce disk sizes. If you have a virtual machine, for example, in Azure, so I have a virtual machine, while I can attach, say, an Ultra SSD or a premium SSD, if I'm not using that virtual machine, like I have a test tenant and subscription to do demos in and to blow things up in. When I'm done with those virtual machines, I might want to keep them around, but I can reduce the size, the tiering of that disk to a lower tiered performance tier to help save money. And so premium disks, ultra disks, they come at a cost. If I don't need that 1 terabyte to be an ultra disk or a premium disk, as long as I don't change the size, and that disk size is the wrong term, the disk service tier is what I should have said. I can actually lower that disk from a premium down to a standard hard drive, which is much slower, but I pay less for it. So I do that with all my, and you can script that, you can PowerShell that. So if you're in the cloud, you can actually shut off your virtual machines, reduce the disk performance tier to something lower to help save a few bucks on a monthly basis. I mentioned this earlier, elastic pools. If you're in Azure and are using Azure SQL Database, you get a fixed CPU count, but you also get a fixed cost. So as long as the Elastic Pools will service your workloads appropriately, you can save money by using Elastic Pools because you have that fixed cost. I've got a client in Azure, they're 100% in Azure, and they use Elastic Pools quite often because of that very reason. It helps to, one, save money, but also gives them some steady state cost analysis and budgeting so that they know what they're going to spend on average moving forward in the use of those databases in the pool. This last one, huge, 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 huge. I didn't see in Google Cloud, but AWS, Azure, you have the ability to do what are called reservations. You can reserve the hardware that you want to use. So if you want to use AWS's RDS instance or Azure SQL database or virtual machines, you can sign up for reservations. I know in Azure you can do like a 1 year, you can go to a 3 year. The bigger the reservation, the more cost savings that you can get. So I know in Azure, if you go to like a 3 year, you can get anywhere from like 70 to 80% cost savings rather than just paying as you go on a monthly basis. So if you're in the cloud and you're not doing reservations today, highly recommend that you look at doing reservations. I know when they first came out in Azure, you had to pay upfront. They've actually changed that where you can actually just pay month to month for that reservation, but you still get that cost savings over time by getting those reservations in place. So highly recommend that you look at doing reservations if you're not doing them currently. Quick summary, choose the right service and offering for your workloads. Make sure you know what your workloads are doing so you can pick the right product and the right cloud provider to do what you need. Pick the right location, please think about that. It's not gonna be perfect all the time, of course, but if the majority of your end users are in the East Coast of the United States, don't put your resources in Australia. That just doesn't make sense. Evaluate your appropriate sizing for your virtual machines, even in platforms as a service. Make sure you're in the right tiers to what performance you need. The cloud makes it really easy to throw hardware at things, especially like platforms as a service. I can scale up my client that is 100% Azure SQL database very, very quickly and very, very easily, but it is very easy to throw hardware at that, but it comes at a cost. So make sure you do performance tuning to help save those costs in the long run. You know, if you're in a pickle, you need to scale up temporarily to get through a busy season, a busy sales season, whatever. Totally cool, but you still have to do the needful things and do the maintenance, do the index tuning and all that stuff. And please, 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 again, reservations. I can't emphasize that enough. Please make sure you're doing reservations. Okay. I feel like I just like blew through that. I know we had some technical issues in the beginning. What questions do we have?
Thanks, John. Yeah, that was a great presentation. So we have one question while we're going to kick it over to Mark in a second here. But the one question we have from Saad is, can you put one Azure SQL database in and out of Elastic Pools, or is it permanent?
Great question. So the answer is yes. You can actually move that database in and out of that pool. One of the cool things that I love this technology is that when you do that, you do incur a minor outage, because what happens is that Azure, Microsoft will actually move your database, and so there's a brief failover, and so the outage it could be 5 seconds, could be 30. The trick with doing that is ensuring that your application has retry logic, because it's very much if you're seeing like availability groups and doing a failover, it's the same kind of concept. There's just that brief outage in terms of when that fails over. Your database is fully available up until that point in time, but then you can move those databases in and out of the pools. My client, we use Elastic Pools. We actually have a database that during their busy season, I actually take it out of the pool to give it more specific CPU. But then during their off season, I put it back in the pool to help save them costs. So it's a great question, but yes, you can move those databases in and out.
Awesome. Thanks, John.
Yeah,
All right,
thank
time
you.
to, quick. I know we're getting close to the top of the hour. Maybe we'll run over a little bit, but that's okay. So I'm going to hand it over to Mark to give us a little walk through our SQL Diagnostic Manager tool.
Thank you, Misha. So we'll go ahead and get things started on my side. You know, we host these events to offer the benefits of learning around different parts of the technology for our audience, but also to have that opportunity to share some of the things we're doing with various products in the space of regulatory compliance or performance monitoring, backups. So we have a number of different tools that we offer at IDERA. And based on whatever the topic is, we like to show those different features that are kind of lined up with whatever the topic is. So today we're looking at Diagnostic Manager. I know we have a limited amount of time, so I figure I'd start off with just real quickly introducing the product and the architecture, but then focus on one of the areas of the product called the prescriptive analytics that will help with providing recommendations to help you with fixing different issues in your environment. And this product does support monitoring of the cloud. So any single database, Elastic Pool managed instance in the Azure world, or even Amazon RDS monitoring is available within this tool. I just want to make it clear that this product takes about 5 minutes to 10 minutes to install. And one of the reasons it is so simple to install is that it doesn't require anything to be deployed out to your actual monitored instances. So there's no agents, there's no extra stored procedures that get pushed out or databases created. Everything it's doing from a monitoring perspective is happening remotely. So we have a collection service that will reach out and gather the performance metric data, and then it stores it in a centralized repository. With the latest release, this product is very scalable with that scaled out architecture, which became available in the version 12 release, where you can literally monitor 2,000 plus instances. So for one thing, it's easy to install, but it also can start monitoring right away, and you can hit the ground running with monitoring of very large environments with this tool as well. And it is licensed based on the number of instances that you decide to monitor, not based on the users, but the SQL instances that you decide to monitor. So if you have a team of engineers that need to be able to look at this data on a regular basis, they can each have access to the tool and go in and analyze data. And it has all kinds of different information that is going to be provided in the console. So I'm going to go ahead and switch over to my little VM environment if I can. Let's go ahead and pull this up. And we'll just dive into it here. So this is the Diagnostic Manager console. We've set it up in a way where you can really navigate through the product very easily and drill down into diagnostic data, you know, starting off high level with any of the performance symptoms or alerts, but then drilling into that to get down into the weeds and understand why is that happening. And then, of course, with what I'm wanting to focus on today is that prescriptive analytics. You're able to take it a step further and get even more information about how to actually fix the issues. Like I said, it's scalable, so you'll see right there on the main screen all of your instances across the environment. I have a little demo environment, but again, it is scalable. And then you can drill into different attributes of your environment, like set up different groupings of instances based on whatever attributes you want. It could be based on location or region or department or team or hosted applications or cloud versus on-prem if you want. And you can basically just drill into anything that's showing a critical condition and start to analyze what's happening on your environment. I'm just going to bring up real quickly the different metrics that we're able to monitor with this tool, because this will also show you some of the things we're doing in the cloud space. And right off the top here, you can see Amazon RDS metrics for credit balance high or low, or disk queue depth, or latency issues. Same with Azure DB monitoring. We have various metrics for disk performance, memory usage, max session percent high or low, service tier changes. And just going down the list here, there's also other categories like database monitoring, availability group, latency monitoring or failover scenarios, database space consumption, log space consumption, temp DB monitoring. There's all kinds of different metrics that we are collecting and alerting around within this tool. The product's been around now for over 2 decades, so it's very mature, it's very stable. So, I would encourage you, if you have some time to go out and download the product from www.idera.com. It's out there as a trial with a license key, a trial license key already embedded in it, so you can immediately start using the product. But it has been around for quite some time. Now, what I wanted to show you is that you have various types of data that are displayed in the console, and then I'll stop for a moment and focus on the prescriptive analytics, and then we'll wrap it up. This is the main overview dashboard screen that's just showing you some of those popular areas that you like to look just to see if there's any pressure being felt on that SQL instance in the areas of CPU, memory, disk performance, buffer and procedure cache, temp DB. And you can just kind of scroll across the top here to the session activity, including what's going on as far as current active sessions, sleeping, suspended sessions. Whatever you select from the list, you're able to see the details down at the bottom as well. There's a dedicated view for blocking and deadlocking. I don't have anything right now popping up as a blocking condition, but this is where you would go to see that. Then you can move across to the queries tab to see all of the worst performing queries, even consolidated queries at query activity. Like if there's that one query that's executing 20 times, you can see what the overall average performance has been across that query, across all those 20 executions, or drill into individual execution performance with the statement mode view. And notice we're also highlighting in yellow or red to kind of draw your attention to where different types of pressure would be experienced with different queries. There's also a dedicated query history view. So if you want to just focus on one, let's do this again. You want to focus on the performance of one query over a given date range and time period, there's a dedicated view for that. And query weight activity. You can go in and analyze if there's anything that's been abnormal with different workloads happening across different weight categories, or with different statements that are executing, or different applications. Or if you're in the heat of the battle, you can even go in and look at what's going on right here, right now with various applications, and drill into just one particular application if you want, or then focus on one particular weight type, and then maybe look at what a query is that's causing that particular weight activity or that particular workload, and then drill into that to see the database, or down to the workstation, sessions, users. So you have that dedicated tabular view, and then you have the resource utilization. So again, focusing more on the hardware aspects, CPU, memory, disk activity, and all of this is stored historically, so we can go back and replay what was happening earlier today if we want, or earlier yesterday, or a week ago, or a month ago. Then you have a dedicated view for database activity, including availability groups, temp DB activity, your fragmentation, tables and indexes type of activity as well. SQL agent job statuses, long-running jobs, job failures. We have that monitored and alerted. You don't really have to babysit these views because we're alerting you to any of the problems that pop up. But it is nice to have a dedicated view that you can go in and even export what you're seeing as far as the history goes. And I'm going to just jump over here for the sake of time to the analyze, which is the prescriptive analytics. This is something that you can run on a schedule. You can click it manually and run the analysis in any of these different categories. And this also supports, your instances or databases hosted on the cloud. It'll actually provide recommendations and sometimes even fix-it scripts to fix issues as well. You can also set it up as an alert action, where if there's a particular symptom that pops up, it will execute the analysis. And what you get is something like this. You'll get a report that shows you everything that it discovered in that analysis time period. You can decide how long you want it to run, meaning like 5 minutes, 10 minutes, 20 minutes, and then it will show you in that time period everything it discovered as a potential issue. And some of this is just more of an FYI, but some of this information ties into performance aspects. Like here we have an index with high levels of page latch contention, for example. You can just kind of go down the list here, duplicate index discovered or missing indexes. But here I have a duplicate index discovered on a database, and it tells us at the bottom what it determined was a problem, when it's a problem, why it would not be a problem, and depending on whatever the finding is, it'll give you different recommendations. And like I said, you can see these little buttons light up at the top, and here's the optimization script to actually fix this issue as well. This also ties into query analysis as well. It'll show you if there's any recommendations for various queries that we're executing, and even provide you a highlight on that statement where you need to go to actually fix the issue aligned with whatever the recommendation is. And you can export this out and share it with your team if you needed to. But some of the areas that it would cover, as far as cloud support, it would look for instances that are at 90% CPU, RDS instances that are at 90% CPU, or RDS instances that have less than 10% storage, or if there's a disk latency high, or if the RDS instance size has changed. These are things that you may not be aware of that are happening, but this will actually alert you to these types of conditions. And even beyond the performance aspect, it will also tell you that Azure SQL database auditing is not enabled, for example, or if there's access from all Azure IPs allowed, something that it could be a security risk. Obviously, it'll give you some of those recommendations as well. But there's a lot in this tool. Usually, when we have a more formal presentation with a customer, it can take an hour and a half to go through all the different features and functionalities. So I've kind of blazed through this at this point, but I did try to focus on what it offers at a high level, and then focus on some of those areas that complement what we heard today as far as the cloud support presentation. So with that, I'm going to go ahead and hand it back over to Misha. I appreciate everyone listening to me, and I hope that the information you gathered today was beneficial to you.
Thanks, Mark. Yeah, so that was a pretty quick overview of Diagnostic Manager. As Mark said, we also have resources on our website, and we have a weekly live demo cast with a more in-depth look at the tool. So I encourage you to sign up and register for our various webcasts through our events page on IDERA.com. And then also, as Mark mentioned, you can download a free trial of SQL Diagnostic Manager and our other SQL database tools through our website, just IDERA.com, and then go to the button at the top, Start for Free. So with that, I will end it. Thank you very much for joining us. Thank you, John, for your great presentation. And I hope everyone has a wonderful rest of your day. Goodbye.
Thanks.